Okay, this lesson's about relationships among parallel perpendicular lines if you have more than two. So if two lines are parallel to the same line, so let's say we have this line and it's parallel to the red line. And then the blue line is also parallel to the red line. That would make the blue line parallel to the black line. And you can kind of see in the picture, if blue is parallel to red and black is parallel to red, then blue and black must be parallel. Similar with perpendicular. If black is perpendicular to red, makes a 90-degree angle, and blue is perpendicular to red, makes a 90-degree angle, then blue is parallel to black. Again. So number one, I'm not really going to do a proof of this. I just want to show remember this is the perpendicular symbol. If A is perpendicular to B, so here's A, here's B, and B is perpendicular to C, this is C, and C, I'm going to change color here, is perpendicular to D, so here's D, this is why A is perpendicular to D. And just seems, I would draw sketches, it just makes it a lot easier to draw sketches and you can kind of see what's going on. Okay, here's another one. If a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So if you have two parallel lines, so if A and B are parallel, and this line is perpendicular to it, if this line is perpendicular to line B, then this line is perpendicular to line A. That's basically what it's saying. That was kind of like in our previous example too. Number two, another proof. So in a proof, you write the givens. A is perpendicular to Y, given. B is perpendicular to X, given. A is parallel to B, and Y is parallel to Z. This is all given. Prove X is parallel to Z. So that's going to be our very last line. Probably should have left a little bit of room. If A is perpendicular to Y and A is parallel to B, that means that Y is perpendicular to B. And if we know that B is perpendicular to X, then over here we know that if Y is perpendicular to B and B is perpendicular to X, then the relationship between X and Y is X is parallel to Y. We can conclude from these two. So if X is parallel to Y and Y is parallel to Z up here, then we know that from the first theorem, X is parallel to Z. Because you can kind of just get rid of, if you have X is parallel to Y, Y is parallel to Z, then you don't even need the Y. X is parallel to the Z. It's kind of like the transitive property with parallel lines. Okay, these are simplest to draw out. So if you want to know how A and D are related. So at the end you should have A is perpendicular to D or A is parallel to D for your answer. So the best thing to do is to draw them out. So if A is parallel to B, I'm going to draw it like this. You got A, you have B, B is parallel to C, C is parallel to D. What's going on with A and D? Well, A is parallel to D. That's your answer. We'll draw another one. A is parallel to B. B is parallel to C. C is perpendicular to D. So if I extend this line, then the answer is A is perpendicular to D. A is perpendicular to B. B is perpendicular to C. C is parallel to D. So what's the relationship between A and D? A is parallel to D. A is perpendicular to B. B is parallel to C. C is perpendicular to D. So the relationship between A and D is A is parallel to D. So much easier to draw them out.